So today we will be building a linked list in Kotlin, and if you don't know what a linked list is, I will try to get some additional information on what a linked list is and how it works and put that down in the description. But for this video we will just be implementing it. So the language we will be using is Kotlin, and I'm just going to get started. So we have our main function here. I can run the main function by just selecting run. And yeah, nothing happens because there is nothing in the main function right now. So to get a linked list working, we first need some kind of wrapper class, which is the actual list class. I will call it our linked list. Okay, and a linked list works in a way where every element knows the next element. We will just be doing a simple one-way linked list for this example, and I will call every element a node. So we have our linked list and we have our node, and in the main function I'll create our list, our linked list, like that. And so to test this list I won't be using JUnit or anything fancy. I'll just write the test right in main so we can see what's happening and see if it's working. So if you were building a general purpose linked list, you would use generics or something like that, but I'm just going to go with string. So I'm going to say that every node will actually hold some data, which will be of type string. And important for each node, as I mentioned before, they need to know which the next node is in sequence. So every node will also have a reference to the next element in the list. Go like that. So we won't have we will have an immutable reference to the next element, and it will be node question mark. So if there is no next node in the list, it will actually be null. And why we do that, it will be more clear later on. I don't think I need anything else in the node class. Remove that. I've created a little description here, so it should be possible to add, get, remove objects, and also get the size of the list. Okay, so we created our list, and the first thing we probably want to do is to add something to the list. So let's create an add function. So we have fun add, and this is a string list. So let's say we add a string. It's a void function, so we don't need a return. And then we need to add that data string to our list. But where do we add it? So a linked list needs some kind of reference to its nodes, or to at least one of the nodes, since the nodes are actually connected to each other. So let's create a reference to a node, which will go first. So this will be a reference to the first node in the list. And Kotlin says it needs to be defined, so let's say it's null. So a couple different cases here in add. Either there is a first node or there isn't a first node. What I mean with that is either the list is empty or there's data in the list. If the list is empty, we just want to set the first node to our data. Or if the list is not empty, we need to actually find the last node and then add the data to the end of that node. So this will actually be an add last function. It's usually the way that add functions work. I just call it add. So in the case that first is actually null, we just want to set first to our new node. So if first is equal to null, then we'll actually say first is equal to our new node. Let's create our new node here. Well, new node equals to, it's a node and it has the data and no next node. So we create the new node as data and no as next, and then we check, is the first element in our list null? Then we set it. Then we set the first node to new node. Else we actually need to find the last node in the list and say that the node that the next element from that node is our new node. So to do that, we actually need to find the last node, and finding the last node is something you usually want to do. So I'm actually going to create a helper to find the last node. So I'm going to say wall last node, and that's going to be a node, and the getter I'm defining as, let's see. So what we actually want to do in get here is we want to iterate through all the nodes in our list until we get to the last node. So if we do this, we do var, or we do var current node, and we set that to first node. So what we see here is that current node will be first, and then we just want to basically iterate until current node dot next is null. So let's see, how do we do that? We say while current node dot next is equal to null, and we say current node equals to current node dot next, and we get some problems here because current node is equal to first. That's an optional node, so we say that current node question mark is not equal to null, and that means that, yeah, that also solved the problem down here. So what will happen in this loop is that we create a current node, we set it to first, and then as long as the next of the current node is not null, we actually step. And what we want to do then is actually to return current node. And you see we get an error here also, because if our list is empty, the last node will also be empty. So actually a last node should be question mark here. Okay, so now we have a function or helper, which is actually a getter, which will pick out the last node by just iterating through all the nodes and finding the last node. So going back to our add, we can actually simplify it a little, or we can remake it a little, because what we actually want to do is we can replace this first with last node actually, if we feel that that is better. I won't do that. I think first makes more sense. Never mind. Okay, first is equal to null, we add it as first, otherwise we will say that last node dot next equals to new node. So we're actually saying that first node, if that is null, we put the new node as first, otherwise we say that the next element of the last node is our new node. And here we'll also get some problems, and depending on what kind of strategy you have for coding, it says here that this last node, which is an optional node, so we either need to do question mark right here, or we need to do an exclamation points or exclamation points. So the difference is that this will crash if last node is null. Looking at our code, last node should never be null if first node is not null, and that's the case here. So I would actually use exclamation points here to force unwrap it, because if this crashes here, we actually get some bigger problems on our hands. Okay, so created add node, last node, and that could be private, and that's a good idea, I think. So let's make it private, like that, and add is good. And then to actually be able to test this, we need to create a get function also. So let's create a get function, get, and let's say that get function is dependent on an index. Good. So to get a node at a certain index, well, let's just make it a bit easier here. Let's just return the first node. This is wrong, of course, but we'll fix it later. So get for an index will return an optional node. usually lists works like this, where if you specify an index which is out of bounds, it will crash. So let's just do that. Okay, so now we have an add and a get function. I can actually remove this, don't need to look at that. And let's now try our list down here. So we say list.add, and let's add hello world. What else? And then we can actually say print line, and we say list.get the first element, get the element on index 0. Okay, let's try to run this. Well, we should also do get the data on node 0. That's actually a good point. The list usually you abstract away the nodes, so list.get0 would actually return the actual item on index 0. So let's change that also. So our get function, since we work with strings, we'll change the node to string, and first would actually be string.data. Okay, let's run this and see what we get. We get hello world. Our list is working. Well, sort of. If we continue here, we can we do an assert here? Yeah, we can. So say why is it complaining? Okay, so let's say list.get 0. That should actually be equal to hello world, not caps but hello world. And if we duplicate that line and we say 1, get the list element on number 1, it should not equal to hello world. Well, this will actually should crash in this case because we only have added 1 element. So let's run this, and yeah, since we cheated, the asserts aren't working. That's good. So let's see. Let's just print, because we're cheating. This should also say hello world, so it should say hello world in our case, but not if it was done correctly. This is hello world, hello world. To make this a little bit a better example, we say hello world 2, and yeah, since you know how our code looks, it only prints hello world twice. So let's fix that. So we need to fix the get function, and it also reminds us that get on index in the index is never used, so we should definitely use that. So how do we use it? Well, we need to step through our list index number of times to get the element on index. So let's create the current node again, and let's set that to first. And so we could make this even more robust and take care of negative integers and things like that. I'm not going to do that in this case. I'm just going to go with a simple implementation. So current node is the first node, and then we need to step index number of times. So for, I think this is the easiest. What can we do? 0 until index. Also, a while ago I did this. And then for each, we actually say current node equals to current node dot next, and we'll force unwrap it. As I said, if you ask for an index that is out of bounds, it should crash. So we'll keep that promise of crashing, and then we'll actually return the current node dot data and force unwrap it again. So what we do here? We say that the first node is the current node, and then we step. I actually don't know if until will work here. We'll see. And the loop parameter it is unused. Let's see what it suggests. Oh, repeat. That's easier. And it actually says count, so we can actually do Thank you, IntelliJ, helps us. Okay, again, from the beginning. Current node is the first node, and then we repeat index times. And we say that current node is the current node dot next, and then we'll return the data of the current node. So if you say 5 times, it will go and say, it will step up and get the node on index 5. So let's see how our main function works right now. Run again, and hello world 2. So I think our getter is working, and you should probably create more tests around this, because this is not very robust so far. But for a small example, it actually works. So let's see, we also want to be able to remove objects, and that's a bit harder, but okay, let's start with actually getting the size of the list. And how do we do that? Size is I will actually create it as a variable up here. So we say private, no, not private, this should be public val size, oops, and it will be an int and get. So how do we get the size? So the size we get through actually looping through and seeing how many next references we have. So I'll create a variable that says count, and it's 0, and then we'll just count every time we can step. So while, we'll create the current node first, again, or current node, and say that the current node is the first node. And while first is not equal to null, we just increase the count by 1, and then we set the current node to current node dot next. Does that make sense? I'll use a question mark there. So looking at the code, we'll say count is equal to 0. We'll set the current node to the first node, and if the first node is not nil, finding errors. If the current node is not nil, we'll increase the count, and then we'll step to the next node. And yeah, and then it actually sees that I don't need a question mark. Good. So we'll step through until the current node next is null, and then we'll step out, and that should give us the size. So we return the size here. And it says it could be private, but not for long. So we'll say less, or let's print line. Our list has the size, and then list dot size. So looking at this, let's make this a little bit easier. Element 1, element 2, and then our list has the size blah. So it should print element 1, element 2. Our list has the size 2. Let's see if it does that. No, it doesn't. It gets a stack overflow. That's interesting. Stack overflow error. And stack overflow error just means that it's this looks like it's referencing itself, so it's doing get size over and over and over again. So let's see what's wrong. We have our, let's indent this a little. Okay, we have a val size int. We create a count variable. We set the current node to first. As long as it's not null, we'll step. And oh, here's actually IntelliJ is actually telling us what's the problem is. Recursive property accessor. So what's happening here is that what we return from this function is the size, which is actually this variable. So when returning this, it will try to figure out what size is. It will go back into this code and do it over and over again. So the correct thing we want to return here is actually count. Okay, let's run that. Element 1, element 2, our list has the size 2. Perfect. So we have one more function to implement, and that is remove. So let's do that. fun remove index. Again, we want to do an object removal, just do an index removal. So if you're used to Java or something similar, there's usually a function which removes an object. So it would say data string. But for this example, I'll use the index and int. So how could we solve this? Well, we need to remove an object, we need to figure out which object should be removed, and then take the node before that and say that that node's next is the node after the node we want to remove. So a little bit complicated, but let's see. So we'll say that the before node, or the before, so we need a node which is before, so a node question mark, and let's say that the before node is let's say that this is the first node. I'm not actually sure how to implement this, but okay, say that the node before is first, and then we want to get the node before the index that we want to remove. So if the before node is first, we want to repeat, we want to step index -1 steps and say that before equals to before.next. So what we're doing here is actually saying step index steps -1, so then we should actually land on the node before the node we're trying to remove. Okay, should we try to do the same thing for the one after? So after equals to first, and let's repeat index +1 times after equals to after.next. Question mark again. Okay, so that should give us the node before the one we're trying to remove and the one after the one we're trying to remove. And then it should be a simple operation of just saying the before node dot next should be equal to the after node dot next. And then some question marks. So, looking at this code, where could it actually go wrong? Well, what if our list is empty? Then before would be null, and after would be null, and then this should be fine because we're optionally unwrapping them. Well, technically, if you remove an index which doesn't exist, it should probably crash. But we won't consider that in this case. So if we remove the first element in the list, and before will actually be first, so that probably is a problem, probably cause problems. So if before equals first, and we're trying to remove the first element in the list, before will actually be, before should be before first. I think we need to do a special case for that one. So if index equals to 0, then we will actually want to say that first equals to first.next, and then return. So what we're doing here is saying that in the case that index is 0, that we're trying to remove the first element on the list, we just want to say that now the reference to the first element in the list should be the reference to the second element in the list. Okay, if that's not the case, we'll go through this logic of finding the element before the one we're trying to remove and the one after the one we're trying to remove, and then removing it. Let's write some tests and see if it works. So let's see if we can say list dot add element 3, and then let's remove, let's say list dot remove element, oh, not element, sorry, index 0, and let's print index, let's print the first element. So what we're doing is adding element 3, we are removing element 0, so this should actually be, it should print, let's write so we don't, because now we're getting a lot of output. So let's write this should be element 2. Okay, let's run it to see. And this should be element 2, is element 2. Let's also print element 1 here, or index 1, that should be element 3, and let's print element 2, and that should crash, I hope. Yeah, it crashes, no pointer exception. Good, so removing element 0 seems to work. Let's try removing element 1 instead. So if we remove element 1, or index 1, it should be 1 and then 3. So this should be element 1 on index 0, and this should be element 3 on index 1. This should be element 3, and it crashes. So that's interesting. What have we missed? So there seems to be something wrong with our remove element function. And that seems to happen when we remove element 1 in our list. Okay, so when we remove element 1, let's try debugging this. So I'm going to select this row, and then I'm going to see if I can run the debugger. Run the debugger. Okay, so now we're in debugging mode, and let's see which line we're on. Yeah, we're on the remove line, of course, because that's the only line we call remove from. And we are on before, and index is 1, and this is our list. So our list has a first element 1, it has a reference to next, which is element 2, and it has a reference to next, which is element 3, and then the next is null. Everything looks good so far. So we go in here and say repeat index -1. So it should repeat this 0 times. So it should not enter this code. Yes, so let's see, before is still element 1. Good. That's good. And then we go to after. So we set after to first, and then we should repeat this 1 + 1 times 2 times. So, and it didn't, or did it? Let's see, after, it did. It just didn't go into the repeat function. So after is element 3, and then we say before dot next equals to after dot next. So there's our problem. Can you spot it? So before dot next is the next element before, and it should not point to the element after. It should actually point to. You can make this a lot easier. So let's remove this. Let's say. So what I'm thinking is, why do we need to find the element? We don't need to find the element before and then the element after. We just need to find the element before, and then take the next, and then the next again, because that's the element after the one we want to remove. So I'm just going to call it C. Let's rename. See if I can remember how to rename. Yes. Let's call it C node for now. So we have our C node. It's the first. We'll repeat it until we get to the node we want, and then we'll say C node dot next is actually see node.next.next. So this looks a bit strange. So we're going to the node before. Since it is the node before, I don't know why I should rename it. Can we rename again, please? No, it doesn't want me to rename, so let's say before. Okay, so first, before will be the node before a node, and we'll say the node before a node we want to remove. Its next should actually be before next. Okay, and now this should hopefully work. Let's remove that and let's run the whole thing and see what happens. So our size is 2, and this element should be 1 is 1, and this element should be 3 is 3. So we have one more case to test, and that is removing the last element. So we remove index 2. That should mean that this should be, the first element should be element 1, and the second element should be element 2. Let's run that, and that works. So I think we're done with a very basic implementation of a linked list. It's a bit to like hold in your head to know these references and figure out the first node in reference to the next node and things like that. If you have any input or questions, feel free to use the comments. If you know any other resources explaining linked lists or explaining concepts around linked lists, please feel free to share those also. And I can talk about more, or I will probably talk about more advanced linked lists in the future, because if you want to make this linked list better or faster, you can, for example, keep references to the first and last node, so you don't need to iterate to find the last node. That makes it sometimes faster to find the node you're looking for. You can iterate both from the end and from the start. That is what's called a double linked list. So if you know the first and the last node, and then every node keeps track of which node is before it and which node is after it. But that also means that we will get a lot more complicated code when we need to, for example, add something, because we need to change the references, or if you want to add something on a specific index, you need to change the references of two neighbor nodes. Remove, you will need to change the references on 2 neighbor nodes. Guess you can optimize to iterate from each directions and things like that. And you could also optimize, for example, size, so that when you do add, it stores the size in an int. So you increase the size when you do add, and you decrease the size when you do remove. But I think that will be all for now. As I said, any questions, comments, or other resources, please share them with me. And hopefully see you in another video. Thank you.